Good afternoon, everyone. So yes, thank you so much for coming today and spending your time on Saturday. So yes, so are you ready to start? We start with the DevOps meetup. Are you ready, everyone? I know the count is less now, but I'm sure within half an hour everybody will join, and we can start in full fledged. But yes, we respect your time. We don't want to delay even a minute. So we just want to start now. Well, what is the DevOps meetup actually? Uh, this has happened almost a year back. We have started, and just between we have some React meetup, we have design meetup and all. So today again we are starting it. Uh, and GeekyAnts. Anybody know about GeekyAnts earlier? So, okay, so how many of you have already attended meetup earlier in the same hall? Okay. Uh, and I think majority will be the first timer in GeekyAnts, right? Or first time for the meetups of GeekyAnts. Raise hands, first timer. Okay, excellent. A right choice. You have taken a decision, right decision today, and I'm sure that the time which you have invested to come on Saturday, it will be valued. To start with, what is GeekyAnts? GeekyAnts is a product development studio with an AI-driven customer-centric approach. As you see, we have 800 plus projects delivered, 50 plus open source projects, 550 plus clients, 30 plus tech partnership, 450 plus team members, and as of now, as AI is trending, so we adapt very easily and faster for the AI thing. And our vision is to have one of the best companies here shortly. So what we do, what we have started a year back, that to attend a lot of meetups, a lot of conferences. So here is a few clips, snapshot which we have taken because we have attended Web Summit, Bangalore Tech Summit, which is in the Bangalore, Web Summit in Lisbon, and we have AppJS conference, which was in Poland last year. So these are the conferences, and also Figma also, which we have attended in San Francisco. You must have heard our amazing products, BlueStack UI and Native Base. You can of course check in the website about the details of this. And we have won the awards also for the BlueStack React Open Source Awards. And Native Base is having 20,000 plus GitHub stars. And BlueStack, as I told you, it's a UI tool here, UI library tool. You can watch the details of the entire thing in the website. Code of conduct: do not use a hate speech and inappropriate comments. When the speaker will come, you just listen carefully. And in case you have any questions in between, please don't disturb at the middle of the session. You are always welcome for the Q&A, which will be the end of every session. We will take it 4 to 5 questions. If it's delayed a bit, just assume 20, 25 minutes or 30 minutes. You are most welcome to cater that questions during networking or in a break time. And get to know your fellow attendees and speakers. Networking is a major thing, of course. And keep your questions after the talk, as I mentioned, and maintain silence while a speaker is giving their talk. And this is GeekyAnts. You can scan the QR code to join, and you can get the notification whatever the meetups and conferences we are happening. We'll be doing it. And also there are few the entire pictures which will be posting it. You will come to know in this. And this is me, Prem Goswami. You can scan, and you can join me in the LinkedIn. I'll be posting it all the meetups, whatever we are doing it outside this GeekyAnts or outside this particular Bangalore as well. I'll be keep on posting it for you. Yeah, so there are amazing lineup of the speakers today. So we'll be starting with the first one after a couple of minutes. And in terms of from the beginning itself, from the Kubernetes to the Gen AI, you'll able to know the wide knowledge of that. And I'm sure I request you to just take notes also, which will be keep on helping you for the further reference. Yeah, so let's get started for the first one. So his name is Bharath Nallapeta, and he's a senior software engineer at Mirantis, and he will start about the next evolution in Kubernetes cluster management. Can we have a round of applause for him, please?
All right. Can you all hear me? Okay. Hey, good afternoon, everyone. Welcome. Again, like Prem said, thank you so much for taking your time out on a Saturday afternoon. And hopefully we've got some plans in the evening as well. You're in the right area for that as well. Yeah. So my name is Bharath. I'm a senior software engineer at Mirantis. I work for the open source program office team. So just a little bit about the team. What we do is we empower open source softwares. We use them internally, and then we also try to expose them and illuminate them to the world as well. Um, as you all know, more lately than before, the adoption of open source, either in individual projects, development projects, or even enterprise, has become really good, right? So one of the latest shocking news from Microsoft is that they have literally open sourced Copilot, which is one of their really, really powerful tools, right? You might be wondering why open source, things like that, right? So there's obviously community, advantages and benefits, but apart from that, there's also benefits for the company. So the companies, although they open source, in fact, like GeekyAnts React framework, which Prem showed earlier, is one of the better examples of that. They're building such a powerful company and a team and a product around it, even though most of it is open source. One of the more powerful examples of companies that does this is Red Hat, right? So every product that is developed in Red Hat has an upstream and a downstream component. Upstream is the open source upstream version, and then the downstream is the company version. So almost like 95 plus percentage of the code will be same, contributed back to the community. About 5% or so will be certain enterprise features and security features, which is the value add that companies do, right? So that's what Mirantis is doing as well in almost all the work that we do. I'll talk about the project and everything in a bit, which again, from the roots, it's open source. Right? So diving into this, just let me get an understanding of the crowd. How many of you all developers? Okay, and DevOps engineers, platform engineers? All right, so about half and half. So it's it's an exciting time, no, for DevOps, especially because the evolution of DevOps, if we see, has really come far, especially in the Kubernetes world. If you talk about it, right? On cloud, it started really simple. It was this offering where they said, hey, this thing works on my machine, but it doesn't work on your machine, the classic developer line, right? They said, I'm going to solve that problem. So Docker said they'll solve that problem, but they solved that problem only to some extent. Kubernetes took that to the next level. So Kubernetes gave an entire ecosystem around that core idea where nobody can complain, hey, it works on my machine, not your machine, not my problem, right? So they said we'll standardize the way the tools are built, the tests are run, the package is finally packaged and delivered to the customer. This whole process is standardized. And why Kubernetes became so popular is because the ecosystem that's built around it. So it's not just about one thing. You have an entire thing that is built around, for example, the security. There are so many products. Observability is so huge right now. Everybody wants to jump into observability, right? And then deployment is one segment as well, so on and so forth. So quickly what it became is this maze of interconnected components across clouds where you have to like sort of talk to hundreds of APIs and connect them in between. And this is the, sort of the maze that it's become. And now, increasingly, and I know it says the future of intelligent operations, but I think it's no more the future, it's the present. So already we are in a world where everything that we do is AI driven. If it's not, then it'll soon become AI driven. So AI has sort of become the centerpiece of everything that we develop, everything that we build, everything that we ship to customers, end users, enterprise users, whatever it is, it's gonna AI is gonna be there. So with that in mind, we need to build a really strong platform engineering, right? So how does platform engineering differ from typical DevOps? One of the core goals of platform engineering is to provide a self-service mechanism, a self-service portal where you don't have to depend on another team to take care of typical DevOps stuff. So for example, let's take an example, right? Let's say you want a Kubernetes cluster in AWS. How do we mostly do it today? You raise a ticket. What is life without tickets, right? So you raise a ticket, it goes to the DevOps team, and then you wait. And then you follow up, and you follow up again. And if there's a delay, there's not much you can do. Escalate, go up the chain, and this is the whole cycle for every single time. But the promise of platform engineering is that you get a serviceable platform where the front end would look something like a basic form. You fill up the details like, hey, I want a 3 node cluster. It should run 16 gigs of RAM. It should also have a GPU. Let it run this particular image, Ubuntu base, or whatever specialized image that you want, or upload my own custom image. Click submit. That's it. It doesn't go to a team. Rather, it goes to a self-serving engine which takes in this request and then builds up a cluster in the backend. Right? That's one of the promises. And if I just take a couple more from this list of what are the primary enterprise requirements, security and compliance becomes extremely important. So not just building a product, but keeping security in mind and then building security into the core of the product becomes extremely important. That's one of the main goals of platform engineering, right? Talking about the current situation in the market, right? So there was a survey done, last year in 2024, and 76% of the organizations said that we have multi-clusters in our environment. And when I say multi-clusters, it means 2 or more clusters, right? So we have AWS, we also have GCP, or we have AWS, and then we have Azure. So 2 or more, everybody has, because that's the kind of world we live in. Nobody wants to get locked into one particular vendor, right? But the shocking thing is just 29% of them have actually a proper platform engineering basics laid into the foundations of their team. So this becomes really challenging to maintain, right? Now, when you think about a proper solution for this, of course, doing nothing is always an option, right? You can just say it's tomorrow's problem, see what happens, and then go with it. But eventually the technical debt builds up and it will blow up in a way that 10 management folks will be on the line asking what happened, and then you do a RCA and blah, blah, right? So to avoid that, open source is an excellent option. Like I already mentioned, Kubernetes ecosystem is built around open source principles and technologies, and it's really good for the solutions that exist in the market. But the problem is there are so many solutions out there that what do you pick? What works best for you? So in any category, you see there are like 10, 15, 20 companies offering exactly the same thing, slightly different, right? So that becomes a complicated challenge for you to manage it. Then there's a proprietary solution. Yes, it's great. So if you just want one company doing everything for you for that particular cloud, it works well. But like I said, nobody wants to get vendor locked in, right? So we also what happened with the famous Broadcom VMware example, but there have been more examples. It's just that that's happened at such a large scale that everybody wants to get out of VMware now. That's where we have the enterprise grade open source solution, right? So what I'm going to talk about right now, hopefully you guys got the foundation of the problem we're trying to solve, and how we're going to solve the problem is what I want to talk about. So we take all the good parts of open source, we identify the projects that are doing well, both in terms of the core fundamental technological principles, as well as the community, the support, and the future growth, right? So we take them and then we create an entire solution out of it, giving an end-to-end experience for the user. And that's where Cordant comes into picture, right? So Cordant is developed by Mirantis folks. And it primarily has like 3 main components, right? So this cluster management, state management, and observability. So starting with the last one's easy. No matter what platform you build, if you don't have a proper tracking mechanism, it's going to be useless. So day 2, your engineers and your DevOps people will ask, how do I see the logs? How much am I consuming? What are the metrics? And the management people will ask, how much is costing me, right? So without a proper observability stack, the platform, however strong it might be, will not be a successful one. And that's why we built observability right into the stack. Then there's day 0 cluster management, which talks about handling and managing and provisioning clusters, and state management, which talks about the same thing, but for applications. So let's say you have like 10 Kubernetes clusters across AWS, Azure, and let's say on-prem OpenStack, right? But then one of the more common things that everybody does is install Cert Manager or Ingress. Now, typically I would need to run a Python script or write an automation, pipeline, which goes and logs into all the 10 clusters, installs these scripts, and then manages it, right? But what we've done is by just configuring it at the top level, all these applications are installed across all the clusters, and it's easier to manage them on day two as well. That's state management for you. So this is the kind of stack that I want to help understand. The bottommost layer is the infrastructure stack. So that's your providers. So that's your VMware, the bare metal, OpenStack, AWS, Azure, and so on, right? And then there's the cluster management, state management, and observability. And on the right side, the observability stack is expanded. Okay, so we have something called as catalog. What this is basically an collection of services. So the same thing, the analogy for this is your Play Store, right? So Google built Android, and Android runs on every device. But what makes it awesome is not just the native apps that we get, but it's also the apps that people have built in the community, and then they're uploading it to the Play Store. And you as a user get to download it from the Play Store. That's what the catalog is. So as you can see, I don't know if you can actually see the examples out here like Argo CD, right? Cert Manager, Dagger, External Secrets, and so on. We're continuously developing this. It started out with like 15, 20 apps, and already I think it's reached 40 or 60 services. Any application that has a Helm chart, it goes here and they can install it. And installing is very simple. You can just do Helm install and then the name of the service, and that gets installed on your cluster. So I mentioned we use open source components, right? So these are the open source, some of the open source projects that's used. For the cluster management, K0s and Cosmotron form the base, the core technologies. So as you can see, we've gone with a K0 trademark. So K0S is the Kubernetes distro. You guys have heard about Kind, right? That's one of the most common things or famous Kubernetes distros out there that everybody uses. Anybody heard of K3S? Right, a few hands. K3D, there are so many in the market. K0S is a Kubernetes distro that's primarily supported by Mirantis, but it has also, community engagement as well. Recently, we got accepted into the CNCF, so that was a big deal. And this is the most lightweight Kubernetes distro out there. It doesn't need a, compared to other distros out there. This runs as a single Linux process, as a systemd process on your laptop, and that becomes your controller. So it's so lightweight that I can have my laptop as the control plane, and then I can add a Raspberry Pi as the worker nodes remotely and then support them, right? And the Cosmotron is the control plane manager for the same thing. And just mention about CAPI. CAPI is Cluster API. This is directly under the Kubernetes SIGs, and this is the standardized way to provision clusters across clouds. And that's what we're using. So Kubernetes said, hey, it doesn't matter whether you're provisioning, Kubernetes on AWS or Azure or OpenStack, follow these standard set of instructions, follow the same guidelines so that we have a standardization. And that's the same thing that Mirantis is using too, right? And in state management, we're using something called Sveltos. This is the core project. And in observability, Prometheus, Grafana, Victoria Metrics, OpenTelemetry, and so on, right? So before this, I want to mention one more thing. Just in this open source components, right? In the observability, we also have OpenCost and OpenTelemetry baked in. So what this gives is a powerful way to track all your costs across the clusters. Okay. So right now, OpenCost does support very good tracking in a single cluster. But what we've done is we've taken this OpenCost and then put our own logic onto it, which is again an open source project, KOF, right? Wherein you can track costs across clusters, which are across clouds. This is a very powerful feature. So if you're a manager, if you're the lead of a DevOps team, and you want to understand how much money you're spending every month or every quarter, then this would be a single dashboard for you to manage them across. And just a note on Victoria Metrics, this is an extremely powerful time series database. So unlike your traditional databases for Kubernetes, where the metrics are huge in terms of volumes. The time series database is identified as one of the best ways to store data, right? So this is in the category of I mean, this is yet another category like SQL and non-SQL databases, right? No SQL databases. So this is another one called time series databases, where it's extremely efficient to store tons and tons and tons of data, and that's what we use. And to query that, we use OpenTelemetry, right? So all these again are available upstream, but they're packaged and configured in such a way that it's easy to use out of the box. So yeah, you as an individual developer, what I'd implore is to go ahead and try K0s. It's a very lightweight distro, like I said. You can run it on your machine and see how the control plane is coming up, and then you can add worker nodes also in your own machine, right? Or you can use another device and then add worker nodes there as well. So go ahead and explore Cordant, github.com/Cordant. We even do the project development over there as well, right? So thank you so much. If there are like two things that I'd like for you to take away from this session, right, is that K0s is the single binary distribution. It's the lightest Kubernetes distro. And then Cordant is your super control plane that provisions and scales cluster at scale, right? And that's my LinkedIn. I'd be more than happy to network after this call as well. And just to try to connect on LinkedIn. So I used to think it's a little cliche to connect on LinkedIn and then just forget. But then the more sessions and conferences I'm attending nowadays and meeting people, I'm really getting to know that the problem statement that I've explained at the start is actually a very common problem statement, no matter whether you're a small company with like 5 clusters or a big company even with hundreds of clusters, right? So I'd be more than happy to have a chat, understand how your technology stack is in the company. Even if Cordant is not solving it, no problem. I'd like to know like how your company is trying to solve this problem, or whether you're completely relying on one cloud, whether that's solving all your problems, and so on, right? So yeah, thank you so much. I still have like 2 minutes left. If you have any questions, I'm happy to take.
We can take 2 to 3 questions. Anybody? Okay, I think it's all.
Have a good day, folks. Thank you.
Thank you, Bharath. It was power pack session for the Kubernetes. Thank you so much for that. So we'll start now with the next session of the day, and his name is Aditya Prakash. He's a senior DevOps engineer of GeekyAnts, and he will talk about a mindset for cost-efficient cloud engineering. And believe me, you'll be able to know that how to save money while building on the cloud. So let's welcome him, please.
So hello everyone, I am Aditya Prakash and I work as a senior DevOps engineer too here at GeekyAnts. And today I'll be speaking on the topic creating a mindset for cost efficient cloud engineering. Before I jump directly into the topic, I'll go through some data, the agenda of the talk, and then we'll continue with this discussion. So why am I giving this talk? First of all, coming from a consulting firm, cloud cost is one of the major factors that help us convert our clients. And also, we help them optimize their current cloud solution for cost optimizations as well. So if you see this data I fetched from Flexera's 2024 State of Cloud report. And this basically shows what are the top cloud challenges that enterprises, small, big companies face when they start using cloud. And the top one being managing cloud spend. So why does this happen? Sometimes something definitely broke in the process, right? That is why cloud spends, you start getting high bills and all those things. So what basically happened? Maybe you did not include cost analysis right when you were building the architecture. Maybe stakeholders are not that cost aware and they are just feature focused. There are certain fears and confusions that the business owners have, because of which they might, just simply go ahead and over provision this architecture. What exactly is causing this unexpected overspending? So in this talk, this is not about, talking about certain coupons or using spot instances. Those are quick fixes. We'll basically discuss how do we make that cultural mind shift towards building less, you building more with less cost, because cost awareness needs to be a core part of engineering. So as the agenda begins, we'll start with how do you think towards cost? How, what are the various reasons, solution, pitfalls, fears that one might have because of which you start getting high bills? Who are the stakeholders? Throughout the presentation, I'll also discuss about some of the experiences that I've had, and I'll also give certain examples as how increasing cloud cost can start affecting your profitability. And lastly, how do we build the mindset and how do we move towards this culture? So to begin with, cloud cost should be treated as a feature. In today's world, we are treating latency as sacred, uptime as paramount, performance as paramount, but cloud cost, usually an afterthought. And when do you start thinking about it? Usually you think it right when you are starting with the architecture, and then when you start getting those cloud alerts, as then you are spending way too much on the cloud resources. So maybe by then it may happen that your user base has grown that much, or maybe say your application has become that complex that it becomes difficult for you to now scale down the resources and bring down the cost of the infrastructure. So there needs to be a sustainable solution and not just lower bills. Again, I would like to remind that cost cutting is not cost efficiency. For example, say you get a you get an alert from the cloud saying RDS is something that's taking up most of the bills that you are paying and on a recurring basis. So you cannot simply go ahead and reduce the RDS size. That will anyways go ahead and affect the performance, the efficiency of the application, thereby touching the user experience. So cloud cost should be embedded right into the process right from the beginning. Next, let's discuss some of the reasons, some of the pitfalls, and how can we, create solutions around it. And usually these are few things that we here at GeekyAnts do when we face those questions from our clients. Smart scaling. Okay, so what happens when you start learning AWS? What are the first few things that you learn? You start by creating an AWS account. You learn about the VPC. You learn about the EC2 instances, security groups, load balancer, and boom, comes auto scaling. So auto scaling sounds very cool, but it's there in almost every cloud native tech stack. But is it always the best solution? No, it's not. If you're not using scaling properly, it will go ahead and simply amplify the waste that you are putting into the cloud costs. So let's divide, say, scaling into basically three types. One being auto scaling, second one being predictive and manual scaling, and third one saying no scaling at all. So we receive few of our clients who usually have building, just an MVP product. They are building maybe just few static pages with a basic backend, and they just want to gain the insights in the market, but they also want scaling. So first you have to understand the business requirement, that why do they want scaling? Do they want scaling because it's a need, or is it just because of the fear? And is it just because of this fear that they want to over provision? So maybe there are times when no scaling is required for your application. There are even, say, applications that receive seasonal traffic. So at that time, you can go ahead and, have predictive and manual scaling. And when the traffic comes down, you can go ahead and remove the extra instances or the over provisioning that you have done. Lastly comes auto scaling. I'm not saying scaling should not be there in an option, but auto scaling should come with certain guardrailing. So how do you decide it? So either ask the business owner whether, say, you need scaling or not. Do you understand the traffic? Is your code bad because of which it's not performing? you need to consider all these questions. So instead of jumping directly into auto scaling, business owners should invest wisely into tools like, using K6, artillery, start load testing onto their application so that they are able to understand what are the breakpoints of their application and when do they want to scale. So auto scaling with data points in place is something that will definitely help, but simply blindly applying auto scaling is something that is not going to be a sustainable solution. Next, fix the app first. So something, if your say your code is bad, this is something that leads eventually to overscaling and over provisioning. Say if your code is bad, how much ever space you give, how much ever scale you give to your infrastructure, your app will go ahead and take that space. And again, after a few days, you will start getting the questions of how to scale, what to scale, and all those things around. So it's better that you identify the bottlenecks right at the beginning of your architecture. And I would say one thing, that fixing code is always cheaper than scaling infra. I'll take you through a quick example. One bad query can result in huge amounts of, say, lakhs lost when you're paying the recurring cloud bills. So say you are using a server that's costing you what? $10,000, 10,000 rupees a month. Just an example. And say you have several bad queries. Bad queries like maybe there is not proper indexing in place, there are redundant joins, optimized paginations are not there, because of which you find out that for your application to run properly, you need 200 servers. So say if you need 200 servers, what's the monthly cost? It will go roughly to 20 lakh rupees a month. So say rather than go ahead and scaling it to 200 servers and spending this huge amount, rather 1 week a dev team should sit together and understand the performance bottlenecks that are there in the application. Maybe they go ahead and reduce the response time by 10 ms, or say the optimizations that they are doing reduces the CPU usage by 40%. So this will drastically reduce the number of servers that you need. Now, instead of 200, you might only need 120 servers, and you will get the saving of rupees, roughly 8 lakh rupees a month. So if you think of this at scale, you add few more zeros, see the amount of cost that you are burning. If say you are at a very, you are a mid-sized company, then remove certain zeros and see if you start indulging in these practices, you will start saving the cost initially. And if you are saving this, I suggest pay the dev team certain bounty who has resolved this. Next comes observability. Observability is definitely important, but observability without thinking and simply, just going ahead and adding distributed tracing, adding logs with less log retention policies, adding undue need of adding application performance monitoring, and all those things can also start burning your cost. So observability is something that is vital, but overdoing it may just, without a plan, waste budget and cause alert fatigue. So you should invest in observability, but only when there is a need, and the dev team needs to keep in mind what amount of logs they are pushing, and also the infra team needs to keep in mind what amount of logs they are preserving. Next, asking the right questions around. Coming from the consulting firm, this is one of the practices that we always indulge in with our clients. Why do we do it? It helps the client gain confidence onto us so that they can continue on a longer term with us. We always tell the clients to avoid the trap of bigger is better, and we should start at a low level and then grow based on data. You should, go ahead and ask and understand the business requirement. You should ask questions around what kind, as I said, what kind of scaling do you need? What kind of load do you expect on your application? What are the traffic patterns? If the client does not know it, you have to go ahead and ask the business owners that they should invest wisely on tools that help them understand this. This will not only help them gain confidence onto us, but this will also help us gain confidence on the infrastructure that we are building and the solutions that we are providing. Because then at a low level itself, we'll try and understand the bottlenecks so that when we scale, we remove those bottlenecks and we can start saving the cloud cost. Next, who are the stakeholders? Is it only the finance team who is paying the recurring bill? Or after the code is shipped to production, is it only the responsibility of the DevOps or the infra or the SRE guys to go ahead and manage the cloud costs? No. There are different stakeholders, even from a software engineer, one who is working on a product, right to the business owner. So developers, when building, should always keep cost effectiveness in their mind. They should always inculcate the culture within their team to ask the questions around that whatever query those people are writing, whatever code that they are writing, will that code be cost conscious or not? Next, the SRE, infra, and DevOps people should not simply go ahead and over provision the infra. They should provision the infra that is required by an application. Infrastructure is something that will not be something same for all the businesses. You need to plan, design, and then implement. Then even architects play a role. How they are designing the app, how they are designing the databases is something that also counts into cloud cost. Product managers need to align their features. They need to understand, the trade-offs between cloud cost, the features, the performance, the latency, and then make decisions around. And the finance team who has to decide what amount of money they want to spend on the infrastructure. I'll give you a small example. Maybe say some business owner comes to you and he wants you to design the infrastructure. How do you do it? Do you simply go ahead and tell him you start with EC2, but then he will ask how will you easily scale? Then would you suggest, okay, if you want scaling, directly move to managed Kubernetes? No, that's not the solution. How you can solve it is start with, say, something like K3s. Boot up a small cluster on EC2 instances. So say if a standard EC2 deployment takes $200, and a managed Kubernetes cluster will take roughly around, say, $800 to $1,000. So if you start with K3s, you get easier scaling solutions also, and you don't overspend as much as managed solutions as well. So it's roughly around 300, 350. You can go ahead and deploy the application and invest some amount extra on understanding the bottlenecks. Lastly, I would say building a culture of cost awareness and governance. How do you start building this culture within your team? As I said, all the stakeholders need to understand their role. People need to start taking, accountability as to whether their actions at scale will affect the cost or not. You need to, as I said, understand the business process, understand the requirements, ask the right questions around what kind of infrastructure do you need, design the infrastructure properly, and have smart scaling in place as well. Using all these things and having the proper cost governance will help you build sustainable systems without breaking the bank. Because if you start inculcating cloud cost into your daily discussions, maybe per sprint plan or maybe schedule it per month, you will start adding more value to your application. And once you start thinking about cloud cost efficiency, start thinking about value, this comes under a bigger umbrella. When you start thinking about that, you will eventually start solving performance issues, latency issues, and thereby improving the user experience. So for people who are already doing it, probably this talk will help you, think or maybe add more pointers to how you think. And for people who are not, I hope this talk becomes an eye opener and you start inculcating this into your, daily practices. I'll be more than happy to take any questions, or maybe if somebody has opinions around this, or, I'm also happy to hear any experiences if you want to share.
Hi, this is Ram Prasad. Hi, I'm working as a cloud architect. So I found that there is a gap between architects and DevOps. So generally, when the solution is designed by the architect, and it will come to the DevOps, so they don't understand what are the consideration they have taken during the solution design. But DevOps has to face how to scale up and cost. It's like it becomes a later task, not initial design. Something they might have missed, but during that operation phase, so there are so many cost related issues. So why that instant has taken, and then what to do? So how do you see that can be resolved?
Okay, to resolve this, firstly, DevOps, you need to collaborate. You cannot, simply say that the architect has given me a solution and I'll start and going ahead and implementing it. As I said, you need to ask the right questions around, maybe to the architect as well. And also this cloud cost issue that you were saying maybe comes at a later stage after the application infrastructure has bloated a bit, or maybe you are so deep into the architecture right now that it's a bit difficult to start scaling down things around. So inculcating cloud cost discussions regularly with teams around is something that can solve the problem for us. Yeah.
Thank you. Another thing is I found difficult to give explanation to the cost related to the developers. They don't mind how much cost it is taking. So they wanted the features and it should be running. So there, how can we have a cost discussion with the developers?
First of all, bring in the project managers also, because project managers decide what kind of features are going. Maybe it'll be better to explain to the project managers the, trade-off between the cost and the type of features that they are pushing. Secondly, with developers, what you can start with, what I usually do, I'll tell you. When usually this kind of things come and usually the dev team says that we have already pushed the code, we have created this feature. First thing I do is I go ahead and start and implement APM. I give them all the heavy database queries that they are running. I ask them to analyze it, whether it's a write intensive query, whether it's a read intensive query. And at the same time, I start performing load testing on the application. So in the time that they are optimizing things around, what I say they come to me saying that this application is mostly read intensive and less write intensive. So maybe what I can do is add up, say if you are using Postgres, we add a PG pool layer in between, so that write queries start going to the write instances and read one starts going to the read. Some part of it is optimized there. Then when I introduce load testing, I tell them that this is, say, 10 requests per second is the standard amount that we expect per second. And to bring them into the cost, you have to show data to them. So this is what I do. Say I expect 10 requests per seconds on an application. So I give it to them. I say, see, your application is not performing well. And in the meantime, when they are optimizing it, I restrict the application to accept only 10 requests per second and push the remaining in queue, thereby not overwhelming the database. So once I start giving the data points to them, it becomes easy for the TL and developers to start thinking into the particular right direction.
These things you do in the QA environment or you do in the development environment?
Okay, so when these issues come in, APM and something is easier to introduce, right? So I introduce the APMs, maybe say directly into production, because that will not break the current application. But say when I have to do the load testing part, I have to boot a pre-prod infrastructure wherein I generate and test the load around.
Thank you so much. Thank you.
Anybody else?
Yeah, hi. Most of the time, when we do the bill of material, right? Whenever before we are starting a infrastructure hosting, we will do the bill of material preparation. Most of the time, we end up with a high amount only. What we prepare in bill of material, we will end up with a higher than that only. So many times you see like a customer used to put a blame like why the spend is we are exceeding the lot of money we are spending. So how we can plan and align over the years with the same amount of money, what we plan in a bill of material and aligning with the over a year for that spend, how we can do that?
Okay, so to first of all, as I said, understand the business requirement. If it's an MVP, then maybe what you have decided, the difference will be not much. But say if you are planning for a large size company or say for a enterprise level client, you have to first of all tell them that there will be some amount of buffer. Lastly, as I would say, to be accurate, this is something that comes out of experience. I mean, say somebody who is maybe say 1.5 years of experience, he will simply go into the AWS calculator. He'll calculate, he'll say this much amount of data I want to use, and he'll give a cost. But if somebody who has a bit of experience can start and analyzing, say, what is that one unknown thing that, increases the cloud cost? Is the network ingestion. We don't know the value usually. So if somebody who has an experience, this can mostly be solved with experience. He can introduce certain factors which will help you go to the, which will help close that gap.
Anybody else? We can still take last questions. All done? Okay.
Thank you, everyone. Thank you. Bye-bye.
Thank you, Aditya. That was a master class for the entire thing for you. Thank you so much again. So now we will move to the third speaker of the day, and his name is Amoghavarsh Patil. He is a module leader from Aspire System, and he will talk about CloudSketcher, GenAI based architecture tool for Azure AWS and GCP. Let's welcome him, please.
Hi all, good afternoon. My name is Amoghavarsh. I'm a cloud engineer and also a cloud architect and also a developer. Usually used to develop applications in my free time. So CloudSketcher is the first Gen AI based tool where you can design architecture and document the architecture, and also you can generate a Terraform code based on resource based approach or model based approach. You can generate a Terraform. So this kind of feature right now, there is no tools available in the market. Especially you can, whenever you are trying to draw the architecturing, right, you will use the Draw.io, most commonly used, and that is also free of cost. And also recently there is a Eraser, Lucidchart, all those are coming up. Along with that, something similar, I am trying to bring it out, but this is specially Draw.io and other tools which is available for flowchart and other things creation. But this is the first tool which is mainly designed for cloud purpose only. So it supports Azure AWS GCP at parallelly. So why CloudSketcher is required? Already we have a many diagramming tool, but still we need a CloudSketcher because right now everyone is trending on GenAI topics. So my idea is I started this project at 2023 August month. I think now it is 2 years. I have built this tool single-handedly. When the GenAI got launched, ChatGPT came into market. My first idea came is CloudSketcher. We need some diagram drawing tool which is mainly you generate architecture and diagrams. Some main problem I wanted to solve is, so many times you will be professional and you will be having experience in one cloud. As a cloud architect, it is very hard to get expertise in Azure AWS GCP. So my idea is simple. If you are a Azure architecture, you can draw the Azure architecture diagram for any problem statement and convert it to other cloud in a single click. So it is going to save at least 80 to 90% of your time. So why you need to generate a diagram for multiple cloud? Most of the time customer comes and he will give the problem statement, what he wanted to host the infrastructure. And then he will, most of the time he wanted to see diagram for Azure, AWS, GCP, all three cloud he wanted to see. And also he wanted to see pricing across multiple cloud, and then he will choose one cloud among it. So he will not choose all three cloud. But he will choose, try to find out what is the difference and which is the best option to go with. So that is the main idea. I am coming with the CloudSketcher. So it has come up with the multiple features. One is you can draw the diagram and you can convert to multiple cloud, Azure, AWS, GCP in a single click you can convert. And along with that, I also have a feature called Sketch Draw, Sketch Vision, Sketch Docs, and also Sketch TF is the upcoming version. It is coming. So what Sketch Draw will do, if you just give a problem statement, what you are trying to solve or what you are trying to host an infrastructure, it will generate a basic diagram, what it is needed. Like if you just mention like I wanted to host an e-commerce application, right? So it will tell like we need a Azure CDN and then backend services we needed and web app is needed, Azure function is needed. Those kind of data it will give, and we need a backend databases. Then monitoring purpose, we need a Azure log analytics and keyword for storing a secret. Those kind of entire architecture diagram with connection it will bring. And sketch vision. So many times whenever there is a small scale architecture, generally you will have those architecture diagram available as an image in a Google. If you want to fine tune small changes in that, so you can just upload that diagram in my tool and it will convert as a editable diagram. So on top of that, if you want to change anything, you can change it. And then sketch docs. So once your diagram is ready, entire diagram is done. So if you want to generate a document, even you are in a call with a customer, if you just do these things in that time also, it will generate a first basic version of document, and it will also give what is the expected pricing. So if you just give like, hey, this is my development environment, this is my project name, this is the problem statement I am going to solve. So just give me a document based on the architecture diagram I have already done. So it is going to give the documentation as a Word format, and also it will predict what is the pricing. If you go with the development environment, if you go with the production, if you just give that data right as a text, it will generate a pricing model also in that document. And then we also have a sketch TF is coming. That is mainly for sketching a Terraform or generating a Terraform. So once your entire diagram is ready and even your document is done, so you want to generate a Terraform. Most of the time, like customer used to go with the Terraform. Maybe if you have heard a Terraform, you will knowing why we need a Terraform, because many times we don't want to go with the Azure portal to have an entire track on what is my configuration. If you go with the Terraform, we can maintain it easily. So when you give that Terraform in this one, right, architecture, it will capture the architecture, it will capture a document, whatever it is documented. And based on that, if you choose resource based or if you want to go with the module based, and if you can just, there is options will come, like what all the configuration you wanted to have. Like in VM, I wanted to go with the 8 core or a 16 core, that those configuration will pop up. So if you just choose that, it will generate a Terraform modules also. So once it is done, it will give it as a GIF file. You can take it offline and you can do the deployment. That is the next version it is coming. And if you compare with the other existing like CloudSketcher, Draw.io, Lucidchart, and even Eraser is there, right? So most of the things, they are generic for even flowchart and other things. This is the first diagramming tool which supports only Azure AWS GCP. And it is also like unlike like Draw.io, it is also coming at free of cost. But advantage is you can have a document generated, Terraform code generated, and comparison of a pricing model and comparison of a diagramming will come in a single place. So why we need to use this tool is mainly I mentioned. So if you draw it for Azure, you can convert to AWS and GCP in a single click. So it is going to save you 2 times of time when you are generating a diagram for AWS and GCP. Same like also you can save a time in documentation, and also especially whenever the customer gives a new requirement and challenging requirement which is you are not aware of it, right? So if you just give the problem statement, you will get a basic idea like what kind of resource I can go with. So many times because Azure AWS GCP all have 300 plus resources, right? So you will not be knowing which is the best resource going to fit for this kind of problem statement. So you can get at least idea like what kind of resource we can have for this application and all. Based on that, you can draw the architecturing diagram. So right now, CloudSketcher I launched 3 months back around, and so far 2,000 plus users has access to this tool. And also I have a user from IBM, Bosch, and Aspire, Infosys, many MNC companies. They are also started using it. So I request, like many of the cloud engineers and cloud architects are there here, I also request to use my tool once and experience it, and you can give the feedback what you feel about. That is about CloudSketcher. So if you want to just connect with me LinkedIn, you can connect. Before this ending of session, I just wanted to show you a demo also, like how CloudSketcher can help you. So this is my landing page. If you just search www.cloudsketcher.com. So basically, I have listed it like we have 3 cloud platform supporters, Azure, AWS, and GCP, and 150 plus mapped icons and 1,000 plus icons available overall, like even third-party vendors icons you will be using, right? The resources like my or even Terraform and all those things. So those icons also available. You can draw the architecturing diagram. And we have a cloud convert, sketch draw, sketch docs, sketch vision, sketch TF features available already. Sketch TF is yet to come. And you can foster 3x time with your work in diagram generation and documentation business proposals. So when you click on convert cloud, right? So this is the landing page of drawing diagram. So I have tabs here, Azure, AWS, GCP, all 3 together here. So if you draw any diagram like, or if you draw any icon here, and if you just click on convert, right? So it will convert a diagram for both Azure and GCP. So it will load. So if you, whenever you have drawn an entire architecture diagram, like which have a small, medium, or large scale, which will have a 40 plus icons, almost 70 to 80% of your diagram will come ready-made. So you can just take it off and you can do the customization on top of it. And there is a studio sketch. Under that, I have a sketch draw. So if you give any example, right? So I will give architecture diagram for hosting e-commerce app, e-commerce application. Then the thing is here, the entire infrastructure is hosted on Azure cloud right now. And also I got a Microsoft startup accelerator sponsorship. So entire amount they are sponsoring it now. Okay, 1 second. Yeah, you can see there is some, due to my network issue, the icons is not being populated properly. But you will see the entire diagram almost got generated here. So user will be trying to access this application over the application gateway. Mainly you can filter out layer 7 traffic to your application. Then you will be having a Kubernetes as a microservice. And then you will have a storage and the databases for backend purpose and function. You can use it for triggering a whenever there is a cart is happened and all, you can trigger the function. Those kind of things you can do with it. And once it is done, if you want, just give a sketch docs, right? Generate a document for this. Generate document for e-commerce app. So what generally it is, how it is working, right? This entire application is used with the backend Azure OpenAI service only. It's where the ChatGPT has a collaboration with Azure OpenAI Azure, and they have a Azure OpenAI hosted. So your whatever the search you are doing, that data will not be used by ChatGPT to train their model. Whatever the search you are going, it will be safe, and it will all the data will be reside within Azure cloud only. So based on your architecture in diagram, it will generate a document like this with a solution with non-technical and technical approaches. And then also you can see the cost estimation. So by default, it will go with the development environment pricing. So if you go with the development environment, what will be the expected pricing? Or if you also, if you just give like this is my production environment, this is my QA environment, those option is also available in next version of it. This is the first basic release I have done it. So if you select that, based on that, it is going to fetch the real-time data only most of the time. Because I have used a ChatGPT latest model to which will be always up to date with the yesterday or day before yesterday data. So based on that only, it is going to fetch the pricing model. And even when you are in the next version of it, it will be having option to select which core machine you wanted to go and which of the what kind of SKU you wanted to go, like a premium SKU, basic SKU, or standard SKU. Those option is also coming. So you can take that, select that configuration, and it will give a better result with that. And also we have option here, sketch vision. So if you take any image from an internet and if you just place it, it will convert a editable diagram like how it is your same background, right? Just now, same way you can edit it on top of that and make a customization. So mainly theme here is to generate a minimal diagram at least with the GenAI. On top of that, you can do the customization, like even more advanced networking components we need to add it, right? If you just see only application gateway was there, mainly like VNet, subnet, and NSC rules, we need to have it in a diagram. Those things you need to customize it, but it will save at least 50% of your time. That is my idea, and that's what, like, yes, right now I am working for this continuous releases, and Microsoft and Salesforce is the one who is also got a partnership for this project. Yeah, that's my time. Thank you. If you have any questions, you can ask.
Hey Mo, this is really cool, by the way. Definitely something I'll try. So you mentioned like two things, like one question which I already had, you said it's partnered with Azure and you'll use the models from Azure.
Yes.
So does the user get any option to customize and select the models that they want?
Right now, no, but I am also planning to bring along with the ChatGPT model, even DeepSeek and cloud models. Also, I am planning to bring it. That is one thing. But major reason why I have chosen Azure OpenAI with a fixed model. By default, it will pick a latest model. Reason is safe because DeepSeek or if you go to ChatGPT directly, they will use that data to train their model. Most of the reputed companies, MNC companies, they don't want to go with that. That's the reason they will block some of the ChatGPT or some other models also. That's the reason everything I hosted in Azure and I kept it. But I have a plan also that if user is fine, I am planning to showcase some pop-up like this data will be used for training purpose. And based on that, if he is still okay with that, that option will come for a user to choose like which model he wanted to go for it.
All right. Second question is, so there's an option for converting the diagram into a doc.
Yes.
But what if I have a proper doc? Is that a feature that you'd consider that you can upload the doc, which has proper details, like a 5-page or a 10-page doc, and based on that you can generate the diagram?
Yeah, that is something I need to think of it, because most of the time whenever the customer comes to us, right, the first thing he will just give the requirement. Based on that, we will begin with the diagram, then generating a document, bill of material preparation, then going with the deployment. That is the structure we follow, right, wherever you go. So that is the main concept. I kept it, and based on that only I try to bring it up. But I have a lot of things also, like even doing a deployment, going with the Terraform based, that is also very difficult for developers, right? Instead of that, I will bring my own option where user will just configure the things within my tool only. It will take care of the deployment, and even it will maintain a version of it. Those kind of also ideas I am having for future.
It's really cool. Yeah. Thank you.
Thank you.
Any more questions? Yeah.
Hi, this is a really cool tool, and I'll definitely try it. So my question is like the sketch draw, we are just giving prompt to get the architecture, right? Or
Yes.
okay.
Right now it is not doing any. You are asking about deployment, how it is happening, or?
No, I'm just asking. Only we have to give prompt to.
No, you can draw it manually also. Like it's not like always you need to give a prompt only. It's like you can draw a fresh diagram from here. You can pull up any image from here. You can do the connection. Okay. You can give a label text, whatever you want to do. That custom diagramming also there. How exactly draw IO and Lucid Chat, all those works, right? Same way, you can also draw the diagram manually. Or if you don't want to go with that, you can use this sketch draw, draw those things to generate a diagram. So when you go with those things, right, you will get a basic idea like what all the resources you can also have for this architecture, and that is the main theme I wanted to also have.
Okay, and it can calculate the total cost if we give the architecture.
Yes, if you whenever you will just generate a sketch docs, right? So it will capture entire icons, whatever there in a diagram. Based on that only, it is going to generate a diagram. Even you can give the messages here, like this is a development environment for VM. I wanted to go with the 8-week or those things. If you give, it will go with that configuration pricing model. Right now, I have not given. It will go with the default model, the default configuration only. And even in next release, I am bringing that option also, like users need to choose like which environment he wanted to go, and what kind of configuration will be there. If you go with the QA model, what kind of configuration will be used. If you go with the production, what best configuration will be used. Those things also will show, and based on that only, it is going to generate a pricing.
In the sketch vision, if we give a if we already have a architecture and if we give it, yes, then it can convert it to the actual architecture, and it can also calculate the cost.
Yes, so same like you can take any architecture diagram, JPG, PNG. Main thing is that image should be clear. If it is not, if it is a blurry image and all, it will not be able to process properly. If you upload a clear image with high quality and all, same image, it will try to bring it to the diagram only. On top of that, you can edit or you can move the icon location and all. You can do that changes.
In the sketch doc, can we use it as HLD, like high level design? Can we use it that doc?
I didn't get you.
So this sketch doc, it can generate the document,
Yes,
whatever is in our architecture. So can we use it as a high-level design document?
Yes, yes.
We can use
Even that will come with the when you export that document, right? It will give a overview about what is the solution you are trying to build, what is the technical part, like what all the resources you are having. It will give a brief introduction about those services, and also non-technical part about like SLAs agreement. So all those things it will give. And at the bottom of the page, you will also see the architecturing diagram comes with that, and along with the pricing and all entire that data will be captured as a document, and you can export it as a docx format.
It's really simplifying the solution architect job. Okay, thank you so much.
Thanks.
It is really a great tool to solution architect, as mentioned. So I have two questions. One is like, do you have any templates defined best architectures?
In the next release, I'm planning to bring almost 100 plus ready-made templates, 2-tier, 3-tier architecture, e-commerce application architecture. Those ready-made templates I'm trying to bring in my own tool. That if you just click that and you can modify on top of that. That ready-made templates I'm trying to bring with my own list of architecture and diagrams.
What is the format of the diagrams is generating? Is it like JPG or some? Like
Diagram you can export it as JPG, PNG format. You can export.
Okay.
Yeah, if you just click on export here, right? JPG, PNG, and even you can export it as a PDF format of your architecturing diagram.
And it's like, are you saving the old data when it is just used?
No, right now, because of the entire project is developed by me and maintained by me, hosting is done by me. Okay. Due to the cost budget, I am not saving any customer data. But if you want to save this file, right, in a future purpose, if you want to reopen that and edit on top of that, you can save this file in your local and again bring back, and you can modify on top of that. That feature is there. Saving option in your local is there. But we are not saving any data related to customer. First of all, I don't have any database only for this project.
Oh. Are you taking a feature request from the portal? It's like any users are logging and they're expecting features not available. Are you taking any feature request where you can add?
You mean like the feature which is not in there, my tool, and if you want suggest me? Yeah, that feedback form is already there in main page. If you fill the form and if you tell me what kind of features you wanted to have, that I'm ready to work on that one.
Thank you. Thank you for doing this.
Hi, awesome tool. I just had one question. How are you deciding the scale of the architecture? So the architecture primarily depends on how many users I'm catering, right? So for 100 users, the architecture will be different. 1 million users, architecture will be different.
Exactly. Thing is, when user don't give any input, it will go with the default architecturing with the standard approach. What I mean is, when I say basic means, it will go with a very minimal configuration, like basic features will be there, right? Basic, standard, premium. So I'm choosing a standard, and by default, I am giving a backend prompt that it should be a standard approach with normal security features. It will not come with advanced like a web application firewall every time. So it will go with a normal standard V2 kind of application gateway. Those kind of suggestion it will take, and based on that it will give. If you manually give, like I wanted to go with a premium approach for this kind of services, those kind of inputs if you give, that based on that it is going to generate a architecturing and document. So even in, especially in document, I am bringing a particular feature like you should always choose like which environment you are generating a document. So development, it will be very almost 60% lesser cost compared to production, right? When it comes to pricing. So when a user you select the development environment, it will go with the basic features of configuration and generate a pricing according to that. When you choose a production, it will go with the even what is multi-zone resources, placing all those things consideration, it will generate a document. That's how I am planning for next release. Since this is the first release I have done, so many of the things still it is not in a place. Even in next release, I am planning to bring Terraform is a major key role or key change player for this tool that I am planning to bring, and even user needs to log in and register his account, and the ready-made templates I am planning to bring. And advanced document generation also it is very basic now. So in next release we'll see better version of CloudSketcher. Thank you.
Yeah, we can take up the last question.
So So there can be always two conditions that either we already have a diagram or we don't have. So in that case, customer will say, create me a diagram for it. It will create diagram for AWS, Azure, GCP, and you will give the pricing.
Yes.
What if somebody already has this diagram, they upload it, and then they give this cost calculator metrics, like I select a drop
That
down.
will already work by default. I like it's something like a bug only if you just copy that entire diagram and place it in this grid. And if you just go to sketch docs and if you just mention like analyze the uploaded diagram and generate a document for that, it will work for now. That feature is available, but something that manual option I am planning to bring, like a user can upload a existing diagram as a image format, and for that it will analyze. And even one more option will come, it side by side comparison of Azure AWS GCP pricing. That is something going to give a better idea of like which one we can choose, right? So Azure AWS GCP, how you are seeing three tabs here, you will see Azure AWS GCP pricings and comparison of like what will be the pricing for in networking layer, what will be the pricing in compute layer, that high level comparison and total estimated price for all three cloud. Those things also it will come in future. I used React Flow. Basically, React Flow is the main key player. Like initial three time I have failed to attempt to bring this diagram because there is a Giant.js Plus and some other tools already available, but their cost is like 1.5 lakh per year and all. So the React Flow is the main component which is helped me to bring the grid version. I paid only 3 to 4,000 for that, and apart from that, I have used main entire stack is Azure only, Azure Cloud, Azure Storage, Azure CDN, and those things. Even for a backend microservice kind of thing, I am deploying, but I have not used the Kubernetes. I have used the Azure functions because my load is right now that not huge, so I am maintaining with the Azure functions only for backend. For that I used the Python.
Yeah, thank you, Amoghavarsh. This is really awesome. Can we have a huge round of applause for him, please?
Thank you.
Now, guys, we'll be having a break time now. So right now it's 4:15. So the tea coffee is already over there itself at the back of yours. So you can just go now and enjoy the tea and coffee. And please back by 4:35. I hope it's fine. Okay, please. Thank you. Name is Mithun K. He is a software engineer, platform one at GeekyAnts, and he will speak about peeking under the hood, observability for microservices. Can we have a round of applause for him, please?
Hello. Hi everyone. My name is Mithun and I'm working in GeekyAnts from past 2 years as a software engineering platform. And today we will be speaking about observability specifically for microservices and why we need to use OpenTelemetry for observability standardization. Coming to the agenda for the talk, first we'll be speaking about the modern systems. We'll be basically comparing the uh, old legacy systems with our current modern system. And later we'll be speaking about what is observability, the pillars of observability. Later we'll move on to why we need to use observability. And then what are the challenges that we face if you're not using observability for your microservice application. Later, we'll move on to what is telemetry and what are the advantages of telemetry and why we need to use for telemetry specifically for observability microservices. And later, I'll be also showing you a small demo where I have deployed two applications on different classes and we're using distributed tracing over here. And after that, we'll be giving a small final thoughts and Q&A session if you have any questions. So, coming to modern systems or complex, if you remember, how many of you are aware of microservices over here? Pretty much everyone, right? So, for the people who don't know, microservices are nothing but before in time we were using monolith services, right? Where you are putting back end, front end, your CMS, all the code used to kind of go into a bundle kind of thing, and it used to run as a single application. Even if you have to scale the application, you have to scale the whole monolith application. But in microservices, we are dividing the same application into different parts, different small individual parts which are not quite tightly coupled with each other. They might be having, for example, if you are taking a e-commerce application, there are product services, checkout services, user auth service, sorry, and coming to modern applications are complex is if you are using only monitoring with the microservices, the checking for the availability or like if you are trying to figure out where failure happened, it's very difficult because the failure are distributed. Maybe your few microservices might be deployed on a cluster one and few other might be deployed on a cluster, some other cluster. Right? So if you're using observability over here, it will say exactly where the issue has happened, why the issue has occurred, and it will be very easy for the developer or the DevOps team to look into. And if you're using only monitoring in the microservices, you just have to, continuously tile all the logs of all the services in multiple tabs and keep on rolling. You won't be able to, I won't say you won't be able to figure out the issue, but it will take at least 10 times more the time of what you would get it in by using observability. So let's move on to what even is observability. Like I said, observability is next version of monitoring, you can say. While monitoring solely depends on metrics and logs, observability also carries tracing with it. So putting all the metrics, logs, and traces together, what you can do is you can actually detect, or you can say how you can see how your application may be performing in the server, or you can easily, I mean, there's no transparent, I mean, there's more transparency with observability than monitoring. There are mainly three pillars of observability, that is metrics, logs, and traces. Metrics are nothing but like CPU utilization, like time consumed for particular request or something like that. Logs are what you have defined for, suppose you have an example like if you're inserting something to database and you would be logging successfully inserted or the database connection failed or something like that. What the traces will do is it will go into a further step. It will show you the end-to-end map for the whole request cycle. That is, if you are trying to check out for a, I mean, you're trying to do the checkout in an e-commerce application, that might be behind the scenes hitting the auth service, user service, and again coming back to checkout, and it might be hitting database as well. Right? So using observability, you can have a complete map of what is happening behind the scenes of your application, and you know exactly what your application is doing in the server. Why you need to use observability? Using observability, you will get the faster incident response. That is, suppose some of your services go down, and immediately if you open the observability tool and you go to particular error logs, and later you can be just redirected to that particular trace and you know exactly where the thing is failing. And easier root cause analysis in microservices. Each, all the requests will have a trace, right? And that trace will contain number of spans. That span is nothing but the op that the request has taken from different services. Suppose again you're eating a service, and that service is internally eating a function, and that function might be tending to call a new service. So you will have the entire span over with you. It is the trace on the span, and span tool continues until the very end of the request completion. So using the trace, you can be able to detect exactly where the issue is happening and resolve it very fast. No observability. If you are not using any observability in your microservices, I would like to give a real world example that we had a client who didn't agree for observability in the initial stage, and when it went to the prod, actually the issue was initially the application was super sweet, and as the users grow, and the application started to become very slow. And if you go to the server and see, all the metrics are fine, and CPU utilization and RAM usage, everything is in under control, but only the application is slow. In those kind of condition, you just keep on debugging without getting anywhere at the end of the day. After spending 2 days of time, we decided to put observability into the same project, and after putting into implementing the observability in the project, we got to know that DB queries were very slow. The indexes were not proper. This after like the observability addition took only 1 day of time, but we had already spent 2 days of debugging, which will let us know where. So using observability will definitely save your time, and also having a APM with your application is a add-on feature for observability with observability. What is OpenTelemetry? OpenTelemetry is a open source observability tool, which is a unified tool, you can say. It provides APK and APIs and SDKs, and those SDKs can be used for in your application to instrument your apps. That is, even if you are not familiar with OpenTelemetry, you would be instrumenting your app in some way or the other way to export metrics and logs. Right? OpenTelemetry also does the same thing, but once you instrument your application with OpenTelemetry, you don't have to care about what tools you are using to at the back end to monitor. Like suppose you are using Tempo for tracing in your microservices, and you are instrumenting it with tracing. And in future, if you want to change the tool, you need to change the whole application, which will again have a developer's effort into it, and also it's time consuming. But if you are using OpenTelemetry, and if you have instrumented your application once, you can use this, you can change the tool at the OpenTelemetry end. There's one small configuration which is OpenTelemetry's configuration, where OpenTelemetry pipeline will receive the data from OpenTelemetry, and that telemetry data will be exported to the tools that are being sent in the backend. There you can just change the tool from tempo to Agar or Agar to tempo, anything of those sort. How OpenTelemetry works. Like I said, SDKs and APIs are provided by OpenTelemetry, which you can be using for instrumenting your application, right? After implementing the SDKs, you will be exporting the data somewhere, right? If you can see over here, there's OpenTelemetry collector over here, right? All your application data from different distributed deployments will be sent to this OpenTelemetry collector. From there, OpenTelemetry processes this data, and then it sends to the backend monitoring tools, whichever you are using. There's one small configuration file which I would like to show you. It's okay, I'll show it after the class. I was unable to open VS Code actually. I'll be showing this file after the. Now coming to why you need to use OpenTelemetry. Like I said, it's a unified tool, right? You won't be needing efforts again and again to instrument your application. And also changing the tool at any time is very easy with super easy with OpenTelemetry. Also, OpenTelemetry supports multiple backends like Prometheus, Grafana, and Agar, Tempo, etc. Also, OpenTelemetry supports many languages like Node, Python, Go, Java, etc. And like I said, it's one-time instrumentation. Coming to why this setup will save your time. It's easy to integrate. OpenTelemetry also provides auto instrumentation and manual instrumentation. Auto instrumentation is where you don't have to change anything in your code. There's one just small configuration. You just need to call those SDKs and need to specify where you want to export that data, and you need to just start the SDK before you are starting the actual application. And faster onboarding is you don't have to train your developers to use multiple tools for instrumenting your application. You just have to ask them to learn OpenTelemetry instrumentation, and they'll be able to instrument your app. And any tools that you want to use can be reached out to DevOps team, and they'll be helping you with deployments. And OpenTelemetry provides with centralized visibility. That being said, from all the services you'll be exporting to a single place, that is OpenTelemetry collector, from where the OpenTelemetry will be sending the data to backend. So you have a centralized place where you are storing the particular data of your applications, like metric, logs, and labels. And OpenTelemetry, since it's open source, it's very cost efficient, and also there's no much effort in or instrumenting it again and again. So it's very cost effective. Don't have to ask the developers to instrument your applications again and again. So now coming to tools that I have used for this demo using OpenTelemetry. I've used Prometheus for metrics, Logi for logging, and Grafana to visualize the data, and Tempo for tracing. What I have done is I've used two node applications where I have just used auto instrumentation. I've not done manual instrumentation. If you are doing a manual instrumentation, you'll be having even more granularity of your application behavior. So let's get started with the demo. This is instrument setup. Like you can see, I have deployed the API caller service, that is service one in a different cluster, and also I have deployed API server, API service that is on different other cluster with the open telemetry components and all the monitoring tool components. These are the metrics that the OpenTelemetry has sent to our Grafana using our Prometheus. Here, when you go to explore and select your tempo, you can actually search the traces that you want. Here, the traces contains a trace ID for each trace and the start time of that and the service that created this trace, and also with the particular route that this trace is responsible with the time taken at the very end. Suppose you find some trace is taking very much of time. You can just click on the trace and find exactly why it's taking the time. Here I've selected a trace which was taking 3 seconds, but all the metrics and uh, logs were fine itself. Like they are not very CPU intensive or resource intensive, and only the time taken by the application was more. So I just immediately clicked on the trace and saw what is happening. And you can see that service one, it's calling call slow API, which is again internally calling the service to call slow. And if you go and see the query over here, it's taking 3 seconds of time to execute. And it also shows the query that is running in the application. By using this, you can exactly find how much time your each DB query is taking, and you can report it to the developer to optimize the queries. Next use case is error debugging. Suppose you want to debug a error and using you open Grafana dashboard, go to Loki, you search for the error log that for the service which you want to debug, and run the query. You will be getting all the error logs that the service has generated. Now configure it in a way that if you're clicking on the log, it will take you to the tempo dashboard where the whole cycle of the request will be shown. And you need to just click on that. You will to see it here. Like I clicked on that, I clicked on that log and I am able to see a tempo URL over here. And if I click there, I'll be getting the whole trace log of that particular request it was running. You can see that the role dice request was called and internally it is calling service tool. And inside the service tool, this particular function is failing. You can click on that span and you can see exactly which request handler or route is failing. Like this, you can be using OpenTelemetry or tracing or to debug your application more efficiently. The second use case is better performance insights. Like I said, if logs are normal and when there's no change in much, there's no much change in metrics as well, you won't be able to find what is happening inside your application on the server, right? So what you can do is you just like here, for example, I'm running slow API. The logs are fine. It shows the success log, and even the metrics were actually fine. And when you click on that particular log, when I click on that particular log, I'll get that trace link. And once I open that tempo link, I find exactly like why the application is slow. The service one is again calling the service two, where the service two is running my slow DB query. Using this, you can exactly find why your application is behaving the way it is behaving. And later, if you report this issue to the development team, it will be resolved in no time. Key interface is observability is not optional; it is essential because in the microservice the errors are always distributed. So you need to have observability in your microservices. And metrics, logs, and traces answer different critical questions. That is, metrics answers the resource utilization of the service. Logs the way the server, like what is happening inside the server, and traces show you where and why it is happening. And open telemetry, why you need to use open telemetry? Like I said, it's vendor neutral, one-time instrumentation of the application, and you can start using any tools that you want to monitor at the end. And better visibility means faster debugging and more confidence. What it means is if you are able to detect the issue fast and you're able to give a proper fix as soon as possible, the customer trust will be better than if you're only having monitoring, and if your application goes down and if you spend time on debugging the issue for the whole day, your app will be down and the customer trust in your organization will go down eventually. So investing in observability saves time, money, and sanity. That being said, if you're putting in observability from the beginning of the project, and since the observability is in the project from the beginning, you'll be able to know what is the application's requirement and how it is performing. Is it performing as per expectation, or it is taking too much of resource, or the application is as fast as expected, or something like that. So investing in observability early really saves time. Thank you. If you have any questions, I'll take it. Prem.
Hi. So already we are using Prometheus, right, for metrics. Why we need telemetrics there? Already we have using Prometheus, Grafana, Loopkey without open telemetry. So what? Why we need to add telemetry? Open telemetry.
Like I said, and the metrics that you're receiving from Prometheus, it's as per expectation. Like if the RAM utilization is around 20 to 25% in of your server, and even the CPU utilization is not exceeding the what you say from 50%, but your application is slow, you won't be able to debug it, right? Why the application is slow.
Okay. So for this, there is so much effort from the developers more than DevOps, right? So
there's no much effort. You need to show the file in some time.
Okay.
Okay, can I show the file now?
And same configuration. Do we need to use?
Yeah.
So even we use telemetry, do we need to still use Loki for the log collection, or only open telemetry?
No. Telemetry just acts as a collector. It doesn't do anything. It collects all data from all the various resources, that is your microservices, and it processes. And at the end, you need to configure which tool you want to use. The open telemetry will export the data out to that particular tool which you want to use. I'll show the configuration file.
So means we doesn't require different collection. So currently we are using for the log collection, we are using a Loki. So
suppose you want to change the tool in future, right? You have now instrumented your whole application using Loki's libraries. You would have used it, right?
Yeah.
And if you want to change the tool from Loki to say a different tool, you need to again instrument your whole application manually. Right? It will be more effort. If you are using OpenTelemetry, you instrument the app one time, and you can change the tool anytime you want. And that tool will be supported by OpenTelemetry. You can definitely use it.
Okay.
I'll show this configuration file where this is the receiver of OpenTelemetry. First, I will show the instrumentation that I have done. This is the auto instrumentation that I have used, and here I am exporting traces, metrics, and log to OpenTelemetry endpoint, right?
Okay.
And OpenTelemetry will be collecting at this particular endpoint, and it will process the data. This is the pipeline responsible for importing and exporting of the data. That is, OpenTelemetry traces data will be received at hotel service end, and it will be exported to this particular hotel. There have configured exporters over here. This hotel is nothing but the tempo exporter, Prometheus, and Loki. If you want to further change the tool from Loki to a different log, you need to replace this Loki with the logging tool you want to use. And in the service pipeline, you need to scroll down, and in the exporter, I'm exporting it to Loki. You need to just change it to the tool you want to use, and you don't have to change anything in the application. It's a one-time effort.
So all these tools we need to configure separately, or is there any repo where we can use that repo and just update the configuration, it will work? Because currently we are using KubeStack, so where it has Prometheus, Loki, and Grafana. So something like that we have where
OpenTelemetry also has its own Elm repo. You can use it.
okay, it can deploy all these.
Yeah.
Thank you.
Is there any more question?
Any more questions from your side? Yeah.
Hello, my name is Mohsin. Yeah. So how does the OpenTelemetry notifies us if any crash happens? How do I get to know? Do I need to check it every time or?
You can configure alerts using alert manager of Prometheus.
And where can I configure it?
Using alert manager, you need to specify particular configuration, like what you want to monitor and where you want to set alert. It's pretty easy. You can just head on to the Prometheus documentation, where you need to just go to that alert manager section. They've documented it very well. Where you want to
So can I get like a mail or something?
Mail or something? Yeah, should I send you a mail?
No, I mean, can I get a mail if any crash happens? For the
Yeah, you can configure it.
Okay.
Yeah. There are many endpoints like mail, Slack. You can also send it to WhatsApp also.
Okay.
Anybody for the last question? Okay, I think it's in. Thank you, Mithun. Thank you so much for the insights. So guys, we are moving to the last speaker of the day now, and it's going to be really interesting. And you must have seen him for the multiple meetups as a speaker. His name is Turja Narayan, and he is a global platform pre-sales leader of Big Four. And he will talk about DevOps to platform engineering evolution of a tech enterprise. Can we have a big round of applause for him, please?
Connect the
Perfect. Thank you so much. So first of all, thank you for attending the DevOps meetup, right? For GeekyAnts, and again a huge shout out to Prem and the GeekyAnts team, right? They're doing some wonderful work. Very frankly, I think they are the most active meetup group, right? At least when I go to meetup, I see their meetups every month. I know they have the Geek conference also. I think so. Really good stuff. And again, a huge shout out to all of you as well, right? Because you came here on a Saturday, right? And you chose to be here, right? You could have just spent the day with Prime Video or Netflix, but you came here not for the coffee or the snacks, right? To get something out of it. Perfect. So I hope that I can kind of live up to the expectations. So the idea of this talk is DevOps to platform engineering, evolution of a tech enterprise, and I will kind of explain a little bit what that means. Very brief about me, I have been doing this for roughly 14 plus years. Right now, I lead a platform engineering team globally across 5 to 6 countries in a Big Four consulting organization. I am also a platform engineering ambassador, a DevOps Institute ambassador. I'm part of the CNCF platforms working group, and just like Prem is doing here, I also run some meetups. I basically chair the HashiCorp user group and the Docker user group in Kolkata, my hometown. This is just a disclaimer. This is just to save me from the lawyers, right? Because so this is I'm speaking on my own behalf, nothing to do with any company stuff. Okay, guys. So let's start, right? So there are 3 sections, very simple. Section 1 is an introduction to DevOps, because just to set the context, right? So that we are all speaking on the same thing. Section 2 would be something else, which is platform engineering, which is what I do, which is what I hope some of you would like to do after this session as well. And finally, kind of a comparison, right? What is what, right? Kind of demystifying everything. So what is DevOps? I think this was in 2000, there was an O'Reilly Velocity conference. I don't know if any of you have seen the video. That's when the DevOps term was coined, right? So you can understand how long back. So today, if you ask somebody, okay, man, what is DevOps? He will say, oh, I have a GitHub repository. I do a CI/CD pipeline. I create a package. I deploy it onto something, right? So I'm a DevOps engineer, which is true also. To be very fair, that's how the industry is seeing. But originally, it was not like that. If you see that original video where DevOps term was coined, it's enlightening. It's on my LinkedIn thing. So you can also check, or you can reach out to me. I can share you the link. So DevOps originally was the concept that the development and ops team don't really talk to each other normally, right? It's like, okay, the developer has done the stuff. They are shifting it to ops. Ops is saying, no, your stuff is shit. I'm shifting it back to you, right? That's what the whole thing was. And DevOps was more of a cultural change. And to do that cultural change, you needed tools, right? Just by talking, you cannot have culture change. You need a tooling system, many things to do that. So that's what DevOps essentially was. Obviously, it was a lot of focus on collaboration, communication. If you have read some of the books like Velocity, Accelerate, I think you should read, then you kind of get the full picture of DevOps. But obviously, DevOps also is tools, right? And that's what, when you go to an interview, you have to know some of this, right? You cannot just say, I know I have a very good culture. I can help you with the culture of your team. They will say, okay, come back sometime later, right? So that is the thing. So, and this is the most important thing, right? If you see, it's Dev and Ops. So the tools are not only for developers, right? So the developer will obviously code, push it using some sort of a CI/CD pipeline, put it into artifact management system. Then some of the awesome stuff that the past speaker was talking about, right? The observability, everything is needed. As you can see, Rafana is shown here also, right? Somebody was showing, I think. So all of this is needed to kind of come to DevOps. And with DevOps, this idea came that, okay, now that I am this combined team, right? I have a developer, I have an ops, everybody is very closely knit. Then if I build it, I will run it. That was Werner Vogels used to say, right? Amazon used to run on this principle that there is no separate ops team. There is no separate dev team. You have built it, you run it in production. So there is, if something breaks in production, you don't have any ops team to call. No, L1, L2, L3, nothing like that. Everything is with the dev team. You have built it, you will run it. So that was the concept. But over time, what happened is that that concept got diluted, and then people kind of started saying, now DevOps is dead, right? You might have heard some of those blogs saying DevOps is dead. So how many of you think today that DevOps is dead? Any of you think? Hopefully not, right? Because you're in a DevOps meetup. So that's a good thing, right? But many people, you will go and see that DevOps is dead. But the numbers, right? People might say many things, but the numbers are not saying that thing, right? So if you see numbers, the more people are saying DevOps is dead, the DevOps business value is increasing. This is the amount of stuff that is happening in the DevOps. So 2024, $20 billion industry for DevOps, including the tools, staffing. So DevOps is not dead. Same thing here also, we are saying DevOps is not going anywhere. Many of the organizations have really transformed radically If any of you have read the Phoenix project, very awesome book. I have it in my bookshelf also. So that's like, but at the same time, there is some problem. That's true, right? So it's not perfect. So why I'm saying there are some problems. So how many of you have heard about this thing called DORA? Some of you might have heard about DORA. Okay, DORA is a way to measure how good your DevOps is working. Because how can you improve something if you don't measure, if you don't know how it is today, right? You have to first know how you are today, then you can improve. So DORA has a few metrics, right? Some things that you can use to measure the performance and the quality of your DevOps team. So one of the metrics in DORA is lead time. What is meant by lead time? Lead time is the time it takes for something that you have developed to go to production. Okay, so let's say today, while sitting here, you develop something and you check in a code just now. And let's say it goes to production in 1 month, that feature, then you have a lead time of 1 month. Simple, right? Lead time is the time it takes from when you are pushing in the code to the time it is, you can see user can see it in production, not in UAT, complete production, okay? So if you see this, what it is showing, I know it's a small graph, but if you see, there are some people who has a lead time of minutes. What does that mean? You code now, in 2 minutes, you see it in the app. That's the awesome thing, right? That's what we all want, right? But at the same time, you have some which take more than 1 month. And some don't even know how much time it takes them. That is the situation. So you can see there is a wide difference, right? You can see there is a wide difference. Top performers are always doing awesome. They are mostly going to be, let's say, in minutes or something. There are some high performers who can at least have a lead time of 1 day. But then there are other people who are also doing DevOps. It's not that they are not doing DevOps. Everybody is doing DevOps today, right? But some are doing it better than others. Agree? That is what this is showing. Same if I go to deployment frequency. What is deployment frequency? How many times do you deploy every day? The more you deploy, the better, right? Because code, no matter you have written wonderful code and it's sitting on a GitHub repository, who cares? Nobody, right? Unless and until the business can deploy that code, users can use that code and you can bring money to your business, your code is useless, right? It's just a fantasy and it's a hobby. Here also, if you see, there are people who can deploy on demand. You want now, they will deploy for you. Then there are people who only deploy, let's say 3 to 4 times a year, which is obviously not good. We don't want to be here, right? You don't want your enterprise to be in this place. You want it to be in that place, either on demand or at least several times per day. I think you might have heard, right? Amazon deployed once 1800 times a day. It made a lot of news. So that's the level of stuff some people are doing, but not all, even though everybody is doing DevOps, okay? Similarly, MTTR. MTTR represents kind of the average time it takes for your system to recover. Let's say something has gone wrong. I just tell you, man, something has gone wrong. How quickly can you recover the system? Let's say by deploying something which was the last version or whatever. Here also, there are some teams who can deploy, who can fix stuff within 1 hour. And then there are stuff who takes between 1 day and 1 week. So just imagine something has gone wrong and you are taking 1 week to fix it. How will your business run, right? The users you had will go away, run away to somebody else. Same thing with change failure rate. Again, the concept is same. What I'm trying to do all of this, you don't need to know all of this metrics. What I'm trying to say, guys, right? In this sort of meetups is good if you can take away 3 to 4 key takeaways. That's enough. And then you go home, Google and research and all of that. So one of the things I'm saying is that even though everybody is doing DevOps, some people are doing it better than others. That's what I'm trying to say here, right? Everybody is doing DevOps. Some people, the top performers, are doing it better than the bottom performers. Similarly, how much time does it take to create a new environment? So let's say today I ask you, let's say all of you are coding somewhere or the other. So now let's say you have deployed a new feature and you want to try it out on a new environment. How much time does it take to get it? Can you create the new environment yourself? Or do you need to talk to a DevOps engineer or some other team and they will say, okay, man, I'm busy, I will give it in 3 days. Right, those kind of things happen, right? So here also, if you see, there are teams who can do self-service. So this is the best, right? I need an environment. I am a developer. I will just write something. The environment will spin up magically. I will deploy my code, test it, then shut down the environment. If I could have done that, I have no dependency on anybody, right? I could do it as many times as possible. But then if you see, environments are spun up by dedicated ops team. This is very common in the industry, right? You cannot spin up the environment. Nobody, oh, you are a developer, I will not give you access to the Azure portal. Very common kind of a thing you will hear from anybody, right? Which is very weird kind of a thing, right? I am deploying, I cannot see my stuff. Then what? How will I improve it, right? Then there are people who are saying can be created but need to be approved. Again, I will let you, but first you send me an email, I will approve why you need, what you need, how much time do you need, what is the cost and all of that, right? So again, you can see there is the same pattern evolving again and again. Again, same concept, right? How do you provision infrastructure? Do you manage infrastructure via Terraform or something like that, where everything is in a code? Or you generate them on a case-to-case basis, which is the worst, right? You send a ticket, they will deploy a VM. Many companies still do that. Again, as you can see, the top performers are much better. They are saying provisioning is managed as code, whereas the low performers saying ops team will create them on a case-to-case basis. And obviously, all of our enterprises are somewhere in the middle, right? My enterprise is also not in the top. I might be somewhere in the high and medium, but let's say Amazon, Spotify, right? They are at there. And then there is maybe some other very, let's say, non-digital sort of enterprise, which is here. So, as I said, right, what we can see again, and I'm emphasizing on this point again and again, is that there's a lot of difference in the maturity and the expertise between top performers and bottom performers, even though everybody is doing DevOps, right? So what is the secret sauce? So this survey that was done says that the secret sauce was this thing called platform engineering. I will explain what it is, but this was the secret sauce. The secret sauce was platform engineering. So if you see, the top performers said, we have an internal developer platform. That is what helps us to be so fast, to be so quick, to deploy again and again. So that is the secret sauce. And I wanted to set up this contest because if I start suddenly and say, okay, guys, let's talk about platform engineering, you guys say, why? Why should I even listen to you, right? Again, it's a Saturday. Why should I waste my time on a Saturday listening to platform engineering? This is the reason. So top performing enterprises are saying there is this secret thing, sauce thing, let's say, called platform engineering, which is helping them. Okay. Just a quick check, right? Just to see that you guys are. So how can we fix some of the current issues? Option A, DevOps is dead. We cannot do anything. Option B, we should hire better, higher paid DevOps engineers. And option C, embrace a platform engineering approach. Okay, hopefully now you guys are kind of in this area, see, and I will prove it to you, right? Why? What is this thing called platform engineering? And just to kind of keep all of you excited as well, right? On to the next part. At the end of the day, money matters, right? For me, for everybody. Why should a DevOps engineer also learn about platform engineering? I don't think there is much bigger driver than this. See the money difference between a DevOps engineer and a platform engineer. So platform engineers are getting paid more than DevOps engineers. End of story. Even in my company, because I hire both of them, right? So they are getting paid more than DevOps engineers, which I think is another impetus for all of you to know, okay, man, how can I know this thing and increase my salary, right? Perfect. So again, end of section 1, very simple key takeaway message is DevOps is not dead at all. DevOps is increasing, but there are different sorts of enterprises. It's a maturity curve. Some people have been able to get the most out of DevOps, and some people have not been able to get the most out of DevOps. With this, I start with this concept of platform engineering. This is what I told you, right? Those high-performing teams are saying this is the secret sauce. So what is a platform? So let's say, for example, today in your company, you are building a new application, and you need this logging / observability. What the earlier speaker was saying, right? What do you do? So one option is you build a logging solution yourself, obviously using the open source tools. You might use Prometheus, Datadog, whatever, right? But you still need to integrate it, make it secure. You need to buy the licenses, everything. You can do it yourself for your application. Very good. And you can go live with your application. Now, again, I am also in your company for another project. I also need to do the same observability. I also do the same thing. Again, so if everybody in the enterprise ends up building their own observability solution, who is the going to sort of suffer the most? The enterprise. So much duplication, right? Time to market also. So let's say, compare this with another enterprise where you know there is an observability solution and you can just use it. It is completely certified by the enterprise security consultants. Everybody is saying that is the correct way to do. Everything is there. You just call an API and thing is done, right? That would have been awesome, right? In a way. Same goes for everything else. I'm not just talking about logging, observability, authentication. Again, all of our applications need some sort of an authentication, OR, JWT. You can build it yourself, or you can use some sort of a package that is already certified, hardened in the company. So the concept of a platform is, it is a set of reusable entities that has been already built within the company. You and everybody else uses. Only difference. Who is the consumer of the platform? Developers. The platform is being used by developers, not by business. So if I am a developer, I will use the components of the platform to build an application, and then that application might be sold to a business. Right, so we are all developing applications. You might be developing a payroll application. He might be developing a banking application, right? All of you are developing application for clients. These are all business-facing applications. But if I'm a platform team, my client is not the final client. My client is you both. I need you as the person building the payroll application and you as the person building the invoice application to use my set of tools and assets. Okay, so this is very, very important. And why? If I can do this over and over again, then you guys don't have to do the same thing again and your cognitive load will reduce. So you don't have to think about the observability. You know there is a team within your company who takes care of observability. They have made this solution. They are the platform team. I just need to talk to them and tell them, guys, I need observability in my solution. They will give me a small package. I will integrate it. Everything is done. That is secure. That is certified. I don't need to care about the licenses, procurement, nothing. I just use them. So that is the whole concept of platform engineering. And CNCF, Cloud Native Computing Foundation, you might have heard of them, right? They have also now taken a very, very keen interest in this concept of platform engineering. And as I was telling you, I'm part of the working group here for CNCF. So they are also saying it's a cross-cutting layer that ensures a consistent experience for acquiring and integrating capabilities and services for a broad set of applications. Again, this is also very important. The importance is that it should not be, it has to be self-service. It cannot be that, again, to get this observability solution, I now need to send an email and I have to wait for 30 days. Then it defeats the purpose. Then it would have been better, I would have built it myself, right? So it has to be self-service, it has to be automated. I will share you some of the principles, but the overall concept is if you have this central developer platform, it's called a developer platform because the customer is a developer. The customer is not the final business. The customer is the developer. And if a developer needs something to build his application, rather than have to think how to take that thing, he will basically, now you might say, okay, is this not AWS or Azure? I today use them. Yes, Azure and AWS are, that's why cloud computing platform. They are also platform, but they provide the basic cloud infrastructure. They will provide you Azure function, AWS Lambda, all of those, right? Now you will take all of this cloud stuff and build a little bit higher abstraction on top of it. Because an observability solution is not just using log analytics, right? Or using CloudWatch. We all know that, right? It's much more complicated, right? That's why take the cognitive load. So all of that things will be implemented here in a platform. And once I give you examples, you will understand. So then what is platform engineering? The concept of building a platform is platform engineering. So now in companies, you have two types of teams. You have the normal teams who are basically working for business, building business facing application, that is 90%. And then you will see there is a 10% team who is building platforms. So their consumers, their client are the other developers. They don't care about the end business that much. They care about the developers. If the developer can use them very easily, then the developer will use them to build application that will then use their clients. So that is the difference, and I will explain that difference in a little bit. So maybe I will show this view a little bit, which will help you understand this, because this is very important. Again, as I said, right, in all of this sort of meetups, even if you can understand 2 to 3 key things, that is the most important thing. So see, there is a platform team. This is a completely separate team. Then there are product teams. These are the teams normally which are building business facing products. These are products which will be sold to clients or internal products also, but these are business products. These are payroll product, invoice product, shopping product, those kind of things. The platform team doesn't care about that. The platform team is giving you caching, observability, logging, monitoring, compute, network, security, auth. Those kind of things are here. So the platform team is building technical assets that then product team will use to build their product. Understood this concept? So what is now you will say, man, what is so special in that? The specialty is, as I said, every single product team now does not have to build the same thing again and again. Number one, because all of them can use this underlying platform. You might say, okay, then this is, as I said, right, this is Azure only. All of them are using Azure. But we all know that just using Azure is never enough. Then what we are doing, right? Then everybody could have just used Azure and gone. So what is the difference? Because Azure gives you the base infra, but there are many other things you need. So can anybody just say that I will just use log analytics, I'll just use a VM? No, a VM is just an, Azure will give you a normal VM. But in an enterprise, a VM will have this antivirus tool, right? That sort of encryption. These are the basic softwares that will be installed on them. Who installs them? The platform team. So the platform team takes the base thing from the cloud provider. They will never replicate what the cloud provider is doing. This is built on top. This is backend infrastructure. This is AWS, Azure, or Google. So they are using the same cloud platform, but then they are making a much more technically usable enterprise grade, which is ready for your enterprise assets here, and then you just take those assets and build your own product. Same thing is actually shown here also, same concept. See, infrastructure as code or whatever you are using, right? This will all be used by the platform engineering team. They will use it and build their products. So what are some of the products of platform engineering tool? As I said, right? A logging framework could be a product. A file transfer, something could be a secure data movement could be a product. Data ingestion could be a product. So those are stuff that the platform team will do. Then the platform team will expose them as an API. And your business team, who is application developing, who are building business facing features, this is what the client needs. Right? The client will come to you and say, I need a payroll application. Client doesn't care whether you are using Redis cache or you are using log search, whatever you are using, they don't care, right? They need the final thing. But you still need them, right? You need to know, okay, should I use Redis cache? Should I use, for example, for vector databases, right? Should I use Pinecone? Should I use, let's say, FICE? Should I use whatever, right? Quadrant. You don't need to care anymore. Because you know the platform team has given you a vector database that is secure, that has been tested, that has been tried, that has support, full support, everything. They have good patterns, everything. So you just need to call the platform team, get the vector database from the platform team and use it in your application. That is the overarching concept. So there are two teams. Again, I'm repeating, there are two teams within enterprise nowadays. There are many more. There is a book called Team Topologies. If any of you guys are interested, you can read it. That explains this in much more detail. Very, very popular book, right? One of the best sellers. But for your purpose, for this session, there are two teams. Take away with this. There is a team where most of you might be working on, which is the application development team or DevOps team, whatever we call it here. And then there is a team called the platform engineering team who are building technical offerings. All of the application developers are the customer of the platform. Okay, very cool. These two slides I'm just keeping in interest of time. Now, one of the things is that I am saying platform engineering is important. Why should you believe me? Right, I can say anything, right? But Gartner is also saying the same thing. So Gartner releases something called top strategic technology trends every year. So you know Gartner, I think, right? They're like an industry thought leader, right? They have they talk to many CIOs, CTOs. They predict 50 years in advance. So they are saying the fourth most important thing today is platform engineering, right? So that is very important, and they have their own hype cycle. And the most important thing that platform engineering does is it reduces cognitive load. What do I mean by that? See, when I started my career 14, 15 years back, right? I used to just go into my laptop and write code. Nothing else. I did not care about this DevOps, Terraform, infrastructure, observability, nothing. Every day I used to wake up, I used to go to office. We used to write them in Java, right? I used to work in Samsung Research. I used to open JetBrains ID, write my code, Eclipse on, and push it to the source control repository, come back home and do whatever I want, right? That kind of a thing. But now you just imagine today's developers. Observability, distributed tracing, Prometheus, GitHub Action, Terraform, Ansible, crazy kind of cognitive load. So this is what is called cognitive load. Cognitive load means the pressure that is being put on every single developer today. So today this concept of full stack developer, right? Every company, what does that mean? That you have to know everything, which is very, very complicated, right? That's why if you see today, over time, the cognitive load has increased. Earlier, people were developing monolith application. Developers were happy. Okay, I will come, code, go home. But now microservices. Okay, this thing is calling that thing. Okay, what do I know about it? How do I trace it? I have to put this trace ID in every single API call. Crazy kind of stuff is happening right now, right? So, and it's only increasing. But platform engineering can reduce this cognitive load. Because now with this, you don't have to think about a lot of this, right? The distributed tracing is taken care of by the platform team as long as you use that component. So the overall idea of platform engineering is also to reduce cognitive load of developers. That's why it's so popular today, and that's why Gartner is saying it is the fourth most important thing. But it's still a relatively new concept. That's why I said, right, this is still relatively new. We started our platform engineering journey roughly around 2018-19 in my company. Right, as you can see, most of the companies are, let's say, 6 months to 1 year, only a few 3 to 5 years, and only a few is 13.42% is 5+ years. which is very, very, let's say, young sort of a concept, right? But things are changing fast. That's why it's important for you all to at least know about this, so that next time you go to an interview, next time somebody asks you something, you at least know what this concept is and you can go home and research it. So if you see today, 55% organizations are already on board to kind of onto a platform. They're already saying, this is a survey that Google did, right? Across they surveyed, let's say 100, 200, 1000 companies, and 90% are planning to expand the adoption. So if you see here, most of the people, right, everybody they surveyed, only 8% said, I have no plans to implement platform engineering. They're like, no matter what happens, I will not do that, right? But all of the others, the rest 92% are somewhere in the journey. Some are very advanced, some are a little bit advanced. So out of us, right, let's say we have 100 people here and all of us get 100 jobs. There is a chance 8 of us will land up in this company, this sort of companies. There, even if I don't know platform engineering, I'm okay. But for the rest of us, 92, it's good to know platform engineering because your company is already onboarded onto platform engineering, right, in some way or the other. So, okay, quick check again. Why should you learn platform engineering? To get better salary, to reduce the cognitive load of developers, to improve the DORA metrics like velocity, MTTR, all of the above. Perfect, good, thank you so much. So again, key takeaway message. What I said here is, platform engineering is the way an enterprise can get most out of their DevOps investment. DevOps is not dead. DevOps engineers will stay. Everything is cool. DevOps is going good. But platform engineering is what you need now. Right now, the cognitive load on developers is such at a high level that it is becoming crazy for them to continue. Right? So many things. Platform engineering is the solution. That's why I told you that Gartner is also saying, not only me, Gartner is saying this is the fourth most important thing. And I showed you a survey where out of 100 companies, 92 companies are somewhere in their journey, but it's still relatively new. That's why I said I'm part of the CNCF platforms working group. We are still coming up with research papers and all of that. So it's a good time to be there. It is not like DevOps where everybody already knows everything, everything is done. This is still relatively new. This is a good time to be a platform engineer, especially because they also pay more. That's also a good sort of a thing. Now coming to this concept, after all of this I told you, right, you might say, okay man, what is the difference, right? I think this is kind of smelling like DevOps, right? What is the difference, right? I also used to do this. So if you see with high level, the thing is differences. And again, I will not go through each and every one of this, but a DevOps person will use the tools provided by the platform to build applications. This is the difference. Whereas a platform person will build those tools. You understand the difference? Hope? Because that is the most important thing, right? The difference between a DevOps engineer and a platform engineer. A platform engineer is basically a product-oriented approach. They're kind of like a product team within the organization. They're building technology assets that the rest of the developers will use. So a DevOps engineer might end up using what a platform engineer has built. And but the platform engineer will never go and suddenly go to a business-facing application and start working on DevOps. I mean, they can technically the skill set is quite same, right? But the concept is different. The platform engineering group within any organization, for example, the organization where I belong, I am in the platform engineering group. We get paid roughly 30% more than the rest of the org, roughly. That's why it becomes very difficult for us to switch to the rest of the org. Right? So let's say something goes wrong and we try to go to another part of the org. They say, yeah, your salary is too much. We cannot afford it. Right? That's how the situation is. Because we are building the cutting edge sort of tools that the rest of the org will use. And the rest of the org is developers, designers, let's say DevOps engineers. They will use those tools and build. That is also very important. I told you, right? That's a $20 billion industry. But this is now even more cool, so to speak, and paying more and much more interesting. And this is why I'm saying that it makes sense, right? That DevOps, from a DevOps engineer, once you are, let's say 3, 4, 5 years, thinking about moving to platform engineering, thinking about that as a concept, learning about it, all of those. And most important thing is that it's not like I have to do DevOps or platform engineering. I hope I clarified that, right? Both are there in the company. They will be in the company. The platform engineering is the internal part. They are never exposed to the final business as such. They are building internal technology assets, reusable artifacts, all of those things. And then the DevOps engineer will use them. The developers will use them to build business-facing applications. But at the same time, as I said, right, it's a paradigm shift. So it's not like every single company, okay, I was DevOps today. I put a sticker on the, oh, I am a platform engineering. No. Not like that. These things will not work, right? So what we have to do is we have to also align with this fact that there has to be a maturity curve. On day one, I might be just at this level. So for example, my interfaces might be custom process. My operations will be by request. But let's still come up with a platform. Over time, I will be in this process. So this is called a platform engineering maturity model. This is a white paper link I have given. There's a very nice YouTube video which explains this maturity. Everything is about maturity. Let's say we go to gym today, same, right? Today, if I go to gym, I will not have a six-pack abs tomorrow. Same sort of a concept, right? I have to work, I will have to take small steps. Same thing, you can move from provisional to operational to scalable to optimizing. Same concept, right? As I said, operations by request. So initially you might set up a platform, but you don't have automation. People have to call you and then you set it up. So then it is by request, but then it's centrally tracked, centrally enabled, and then you finally provide it as a managed service. This is kind of like the holy grail of platform engineering. Amazon, those companies I was showing, we are doing the most out of the DevOps, they are at this stage, right? So we have to move from the left to the right over time. Finally, our last quick checkup is platform engineering and DevOps same? Hopefully no, perfect, good. Thank you so much again for coming on a Saturday and spending time with us. I hope you have a great rest of the day. Thank you.
Any questions you have? Any questions you can have? Still, we can go for 2 to 3 questions.
Hi, my name is Punarth. I had a question. How do platform engineers identify what tools the developer needs? Because majorly what happens is developer uses tools that business requires it. So it is primarily dependent on what kind of business it is. So how do platform engineers identify what to build?
Again, this is where there is another concept. I have given talks on this as well. So there is a concept called platform as a product. So let's say today I tell you, what was your name you said, man?
Punartho. Punartho.
Punartho. Yes.
Yes.
So Punartho, for example, tomorrow I say, man, can you tell me a cap price comparison application? What will you do? You will go to the customer, try to understand whether there is a demand. You will treat it as a product, right? Same thing, a platform engineering team is also a product team. Platform as a product mindset. If all of you are developers, and let's say this is a company, right? And today I am the platform engineering team and all of you are my customers. I will go to you and say, man, what do you use today? I go to her, I will say, what do you use today? I will go to him. What do you? Then I will try to find patterns. Then I will go, okay, man, if I do this, will you use it? All of this happens in the background. Obviously, I did not show all of that, right? Just like a product backlog. So in my company, if tomorrow you join my company and say, can you tell me what is available? I will not only show you what is available, I can even show you a 1-year roadmap of what I will make in the next 1 year, just like a product. So I know everything that I will do. I take money to do it. I will check whether it's useful. Then once I have given it to you, I will try to measure adoption. We even decommission stuff. It's not like I will, Google also made so many mistakes, right? Let's say Google Meet. Not Google Meet, that there was another Google photos, not photos. There was some
Hangouts.
Google application. Yeah, the Hangouts, exactly, right? It did not work out, right? It did not become the next. So we have also made some things and we have decommissioned things as well. But the idea is that my customer, what you have to understand, my customer is developer and engineer. So I need to go to them. I cannot go to the direct business. And it's very funny that once you start questioning developers, 100, 200, and we have done that, most of them have the same problem. Irrespective of whether they're building an oil product or they're building a, let's say, a payroll product or finance industry. Most of them have the same problems. Okay, I don't know which are the developer tools available. I don't know how to get license. I don't know, can I use this? Can I not use this in the company? Those kind of things, right? Second thing is that I will tell you, when we started our journey, we had 7 source control platforms being used in our company, 7. Perforce, version control system, GitHub, GitLab, everything. But do you really think there is a lot of difference between them? Not a lot, right? So if I can standardize there, then, so today, for example, we are standardized on GitHub. So every new person who comes in learns GitHub and deploys them. So it gives a lot of value. So just because the developer is using something doesn't mean he has to continue using it as well. So the platform team will go there and say, man, you are using today Jenkins. Can you do it with GitHub Actions? Have you tried it out? We are going to make it available. We can help you onboard. So those kind of things. And it's a continuous migration journey. Because people who have already built something, it's not like there is a magic switch that tomorrow they will come onto your platform, right? You have to continue working with them. They might adopt a part of the platform, like it, and then adopt more and more. And finally, there is a concept called habitable platforms and paved road. Sam Newman has a very nice video on this. I can share you the link later if you want. So he's saying a platform should be habitable, means something where a developer wants to be. It should not be something I force on you. If I force on you, know, you have to use this. Then after some time, either you will bypass it or you will start complaining or leave the company. Simple, right? Because you are not liking being in that company because they're forcing you to use a tool which is inefficient. Rather, it should be a habitable environment. Platform consumption should be optional. There should not be a mandate that you have to use my platform. There should rather be a conversation. Okay, why are you not using my platform? What I can do to make you use my platform? Those kind of concepts.
Thank you.
Again, in platform, it's much more complicated again, right? But there is a platform in the university which kind of talks about this. High level, I will tell you. So you need some sort of a portal first, right? A front end. That's called an internal developer portal. A portal is nothing but, so what I say is that many companies, I consult with clients, right? And they say, man, okay, you guys have done such an awesome job with your platform. How can I get started? I said, create a wiki page. A wiki page is also a platform. If you have a wiki page that explains to every developer what to do, that in itself is a platform. That is the most, let's say, basic sort of a platform. But over time, what you'd like to do, you like to have an internal developer portal. So let's say today in your company, you don't know, right? Should I use Mongo or Redis? I go to that portal, I can find everything that the platform offers. So that's the front end. I should be able to click a button called consume or get started, and it will provision everything. But the magic is in the provisioning layer. How do I provision? How do I manage the state? So that is the second layer. So there also you can have custom tooling. It's like for example, we have a little bit of Terraform, some Ansible. So that's where the DevOps gluing comes in. And then there are many companies like Humanitech, Port.io, Tramix. There are many other companies who are also now trying to provide the full page. So let's say you don't have a lot of time and money and investment. You go to them and say, guys, give me the base, Backstage from Spotify. These are all platform companies who are now selling their platform as a service. So you can also install them, or you can, for example, we started in 2018. So we built it on our own. It's like a custom set of many things that we have used below. And the portal is a very nice, shiny web portal with React or Angular, where you can just go log in, see what you can get the bill, everything is there. That sort of a concept.
Thank you so much, Turja. Thanks a lot. It was incredible. And I'm sure everybody loved to have that session. Yeah. So now we are in the end of the session. And thank you so much to everyone who have invested today to come on Saturday. Again, you are most welcome to come on all the meetups we have. As I mentioned, that we have multiple meetup groups. You please join GeekyAnts, Design, React Native. So all those are still on. You can go and you can join for all further meetups. And before I close, thank you so much for coming today. And you are most welcome for all the conferences also, which we have planned for this year and next year as well. So, and once I just, before closing, thank you to our team, because without them, it's really difficult to do that. So Bhushan and Venugopal is the one who is totally handling the live streaming, the entire AV system. And the social media, which you'll be seeing after when you'll be out from this session, the entire post, she is handling, her name is Sana. So you can just clap for her, please. Yeah. And yes, so we are in the closing now. So before that, there are a few stickers over there lying on the table. You are most welcome to take it. And I will request just after a couple of minutes to all the winners to come on the stage. So for all the online viewers now, we are closing, and thank you so much for joining. We'll be coming soon. Stay tuned for the next meetup.